Good morning, Trig and Pre-Calc students. Hopefully you're doing well today. I wanted to go over a few problems with you from the worksheet that was assigned yesterday. Today you will be working on a second one of these worksheets, hopefully feeling a little better about trying to take a graph that looks like a piecewise function and translate and reflect the graph. Trying to focus on the current or the given x and y values and how those given x and y values would change based off of what the function notation is telling us. So if you look at 1 and 2 here, based off of this function notation, when there's something inside the parentheses, we know the graph would shift left 3 units because it says x plus 3. So really we could write this as f of x minus and then that negative 3. Which is why the graph would be shifting to the left because of the negative 3, the standard form having that x minus. So that means I'd take all of my x values and shift them to the left, or I would subtract 3 from all of the x values. Number 2's graph should shift down 3 units, and looking at that part, the minus 3 is separate from the f of x, so essentially this is saying you're taking y and you're subtracting 3. F of x and y are interchangeable. So using the ordered pairs that I have from the given graph, I would take all of the y values and subtract 3 from them and then make a graph. Number 3, the graph says f of negative x, and you can see right in the middle, we're literally taking the x values and making them negative. That's going to force them to reflect over the y-axis because my positive x values are now negative, which means they're jumping over the other side of the y-axis. Again, taking the original ordered pairs in the t-chart, you're making all of those x values negative. So we're going to talk about number 4, because this one is a little different. Notice that the x value is negative inside, and then we have a plus 1. Well, when something's inside parentheses and a negative is applied to whatever's in parentheses, it's applied to both parts of the parentheses. So really, it's kind of like saying I have a negative x, but that 1, the plus 1, was also affected by the negative sign, because if it was applied to the x, then it was also applied to the 1. So I'm going to factor out a negative 1, still inside this f of x function. And when I factor out a negative 1, really I end up having x minus 1 inside the quantity. So when you see an x term that is negative, whatever's inside with x was affected by that negative sign, and we have to think about factoring that negative sign out. This graph, even though it appears in the original form that your mind is saying, hey, this graph is moving left, it actually doesn't. And that's because the x is negative, therefore that plus 1 was also multiplied by a negative value. If I look at this new factored form, I can see that this graph is actually moving right 1. And this is tricky. Yes, the x is negative, so besides moving right 1, it's going to reflect over the y. So reflect over the y-axis, and then it's moving right 1. So I'm going to take the original ordered pairs that we were given, and I'm going to try and apply that information to it. So in my t-chart, there's nothing being done with the y because there's nothing outside of the function. So I'm not making y negative, I'm not adding or subtracting anything with y. So my y values are going to stay the same. So we have 0, 3, 2, 2. Those are going to remain the same. However, the x term is going to change. And it's going to change because it's moving right 1, and the x is also going to become negative. So I'm going to write myself a little bit of information here. I'm going to make x negative, and then I'm going to move right 1. So I have to make x negative first because order of operations I have to multiply by a negative, and then I'm adding 1 to that value. So up here, Looking at the original point, I had a -2. I'm making that negative first, so now it's a +2, and then I'm adding 1 to it. So my x value becomes 3. Going to do that same thing with the second one. I'm now looking at the 0. I'm making it negative. Well, -0 is just 0. And then I add 1 to it to move it to the right. I have a 1. I'm making it negative. Now it's -1. Adding 1 is 0. And then finally, I have a 2. I'm making it negative. And then adding 1 means I have a -1. So again, I use those original values from the x. So I took the -2, I made it positive, and then I added 1. And now I have these 4 new points that I'm going to plot. So the first point is at 3, 0. And then we're over at 1, up 3. We're at 0, 2. And then I'm at -1, 2. So when you connect your points, they should connect in the same format. So I should still have the same shape of the graph. So I have a horizontal line. I have a little curve in my graph. And then I have that diagonal line. But I can see if I compare the two graphs, looking at the original, it has flipped over the y-axis, and it's also shifted to the right 1 unit. So it's flipped and it has shifted right. So that should be your final graph for number 4. Looking at the last two, just kind of explaining what's happening with this number 5. So number 5, there's 2 things going on in front. The negative sign reflects it over the x. The 2 makes it a vertical stretch. And then the +4 moves it up 4 units. Well, all of that is changing the y in the graph. So when you go to make your little t-chart and think about what is going on with your values, the x this time is not changing. It's remaining the same. So the original x values that we had, -2, 0, 1, 2, they're remaining the same because there's nothing inside the parentheses to change x. The y, however, is definitely different because the first thing I have to do is take -2 times f of x. Well, that means I need to take -2 times y. So that's what this -2 is telling me with the f of x. And then I need to move it up 4. So if you take your original y values, I'm going to write them next to it here. So we had 0, 3, and then 2, 2. Those are the original y's. So I'm going to multiply it by -2, and then I'm going to add 4. So multiplying 0 by -2, adding 4. Multiplying 3 by -2, so now I have -6 plus 4. 2 and -2 make -4, adding 4. 2 again times -2 is -4, and then I add 4. Those would be my new values of my graph. So after I get those new values, again, I'm going to go graph it. So my graph should still have the same shape. It should just be stretched more, a vertical stretch. It has moved up 4 units, and it's also flipped upside down. It's flipped over the x-axis. So it should be upside down. So the last graph one here says x minus 4 inside the parentheses, f of x minus 4, and this graph shifts right 4 units. So that means my x value should move to the right 4 units. So hopefully seeing those couple problems was helpful for you to kind of think about how to get the values in the t-chart and how to get your graph. You're going to have a few more problems like this, and I'll show you that in a little bit so that you can see what the worksheet for today looks like. The problems at the bottom we discussed at the end of class yesterday as well. The goal is to write these in function notation. So instead of having y equals x minus 4 quantity squared, I want to get it out of that notation and instead have the notation look similar to what we have up above, where we have the f of x minus 4 or negative 2 f of x plus 4. So we pretty much have to decide, are we using f of x or are we using g of x, because they represent a different function. And if you look at number 7, because it's squared, I would use the f of x function. So based off of the power, whatever's being done with that quantity tells me I should use the f of x since it's a squared term. Inside, I can see that this graph is going to move to the right 4 units. Well, that means when I go to write it with f of x, inside, if I want it to move to the right 4 units, I need to keep that quantity inside parentheses to show it's still moving right 4. So whether I have it written in the equation notation or function notation, the notation is still showing that we're moving to the right 4. So let's go underneath, because the next one also has an x squared. Anytime it has an x squared, that's my f of x function. There's nothing inside the parentheses with x. Above, there was something inside the parentheses with x. This time there isn't. So I would just keep that as f of x. There's a negative in front of the x squared. Well, x squared is my f of x function, so I need to put a negative in front of it. And then it has a plus 5 outside. So this is still saying my function is reflecting over the x-axis and it's moving up 5. I just am writing it using function notation instead of the actual equation using the x squared. The last one with these, again, kind of thinking of it the same way. There's my x squared, so that means I have to have f of x. I would place the 7 in front because we're taking 7 times my f of x function. So 7 times x squared is 7 f of x. And then that's being increased by 2. We could also flip it around if you'd rather have it in the other way. All right, so that would be our f of x function. Now let's look at the g. So we have a fraction for g of x. And that fraction is 1 over x. So that means anytime it has a fraction, then that's our g of x function. So I know right here that we have y equals 3 over x. I could really think about that as having y equals 3 times 1 over x. Those are the same things, whether I have the 3 in the numerator or I pull the 3 outside. I did that to get you to kind of understand that it's the g of x function. 1 over x is the g of x function. That 3 that's on top is really saying I'm taking 3 times the g of x function. So I would write that as 3 g of x. So it's on the top, it's affecting that whole function, taking 3 times that whole function. Whereas if you look at number 10, the x minus 1 is on the bottom, and I can kind of treat that x minus 1 as really having like parentheses grouped around it. So those parentheses grouping that x minus 1 in the denominator, keeping that quantity together, means that the x is being affected because the x is being subtracted by 1. So it's still a fraction, it's still 1 over x, but when I write it in function notation, instead of saying 1 over x minus 1, I'm saying the g function of x minus 1. And then applying that same fact to number 12, again, notice there are parentheses, so there are parentheses grouping that denominator together. Anytime it's grouped with x, it affects x. So it's in fraction form, and then negative 2x plus 2. So g means I'm using the 1 over x function, and then it's affecting x, so I would have that negative 2x plus 2. We could also pull that negative 2 out and write it as x minus 1. That would be another way of writing it. So the x value is actually having a horizontal stretch here, it's going to be flipping over the y-axis because of the -2, and then the graph also shifts to the right one. So hopefully, again, that kind of helped explain this worksheet. If you have questions that I didn't answer, please send me an email. I will be looking over these over the next day or two and trying to give you some feedback on this worksheet. So the assignment that you have for today is similar to this worksheet. It's called worksheet number 2. And pretty much we have another piecewise function. The first thing that I want you to do with this piecewise function is to label the original values. So the directions are the same. This graph is drawn from -0 to 2. That would be the current interval of our graph, but our new graph is going to change. So that's just the current interval that the graph is drawn, just so you know what those values represent. There is graph paper already for you, so each problem has a graph attached to it. And listing those points, we have a value at 0, 1. We have a 1, 1, 1.5, 2, and then 2, 1. So those are our original ordered pairs. So you're going to go through this worksheet just like the previous worksheet and see if you can first decide the translation or the reflection. After you decide that, make yourself a little T-chart. Put some rules or information above the X and the Y right up here so that you know what you're doing with your graph. It might help you decide, how does the X value change, how does the Y value change. So you have 5 graphs to do like that. And then in number 6, kind of getting you to think about an equation and how does an equation change to show that there's a reflection in the y-axis or a reflection in the x-axis. So think about those rules that we discussed. If it's a reflection across the y-axis, which variable is it affecting? If it's a reflection in the x-axis, which variable is that affecting? So try and think of it that way. How's the variable changing? And then in number 7, this graph right here is our h of x graph. It's a little different from the one above. And it is graphed on the interval, this is wrong. Let's cross that out. Actually, it's graphed on the interval from 0 to 5. And your goal is to apply the 3 different options on the same graph that is drawn here. So the first one, you want to take the given function and you want to make it even. So you might want to draw that original function again on the graph paper and think about what does it mean for it to be even. So think about even functions, they have a special type of symmetry. Part B, you're going to take that graph and then you're going to make it odd. So again, what does it mean for functions to be odd? What type of symmetry does it have? And then the last part, it says you're going to make it a reflection with respect to the x-axis. So how would something reflect over the x-axis? Tomorrow I will have another little video for you and I'll explain a few problems on this worksheet. Again, if you have any questions, please feel free to email me. Otherwise, have a fantastic day.